So now let's talk about payout annuities. And this is going to tie closely to what we just did with savings annuities. But what we're going to see is a slight change in our formula, where a lot of the variables will stay the same. The behavior of this account is different than what we were just doing. So a payout annuity is a sequence of equal withdrawals made at equal time intervals. So with the savings annuity, that was like building up our retirement account. That was in terms of savings, starting from nothing and building up our account over time. Now, a payout annuity is the idea of using that account. Like, we retired, so we're going to start taking money out of that account. So savings and payout, it's really in the names there. So in that last video, savings is increasing our account, and this payout is the idea of decreasing our account. So with savings, it was all about making deposits. Here, it's all about making withdrawals, so taking money out of the account. So often with retirement, like we would be making monthly withdrawals. So we would retire that account. What's nice is that it keeps building interest. It's just we're not making our own personal deposits into it anymore. So the account still slightly grows, but the only growth is coming from interest. We're not using any of our money for growth, but while it's increasing from interest, it's also decreasing in terms of those monthly payouts that we're taking. So the payout annuity formula, we're going to see a lot of the same letters here. So A is the account balance. Well, actually, let's talk through the formula here. So A equals, and then in the numerator, we're going to see D times, so we'll have one set of parentheses, we'll have 1 minus, and then in parentheses 1 plus R over N. And then our exponent is going to be a negative NT, and then we'll want to close those parentheses. So some things that change is this kind of order of this -1. Now it's at the beginning, we'll have 1 minus, still 1 plus R over N, that's the same. And now our exponent is negative, and that's coming from the fact that we're decreasing. It's like exponential decay. The denominator is exactly the same. It's still R over N. Okay, so while we're using D here, that worked really nicely for the last formula because it was deposits. Here it just represents the withdrawal. So how much are we withdrawing from the account? So withdrawal amount. R is that annual percentage rate. Again, we'll be plugging that in as a decimal. And then N is going to represent the number of withdrawals per year. And then T is the number of years. Okay, let's take a look at a few examples here. Let's see. We're going to do 2 examples with this. So, you want to be able to withdraw $25,000 each year for 15 years. Your account earns 5% interest. How much do you need in the account at the beginning? So that right there is asking, what is A? So what's the account balance when we are starting? How much total money will you pull out of the account? So how much money are we going to use up? And then how much of that money is interest? So let's start by finding A. So in terms of our notation here, we don't know what A is. D is our withdrawal amount. So we want to withdraw $25,000 each year. So 25,000. The rate is 5%, so 0.05. N, we're doing this annually, so N is going to be equal to 1. And then T is going to be the 15 years that pass. So we want to be able to take $25,000 out each year for 15 years. So with this, finding A, we're going to have 25,000 times 1 minus and then parentheses 1 plus 0.05 over 1, which is just 1 plus 0.05, with an exponent of negative 1 times 15. And close those parentheses, all over 0.05 over 1. All right, let's go to our calculator and plug all of that in. So I'm going to separate my numerator denominator, 25,000 parentheses 1 minus parentheses 1 plus 0.05, and then close those parentheses and raise it to an exponent of negative 15. Close the parentheses in the numerator, all over 0.05. So let's see, $259,491.45. Copy that down. So A equals $259,491.45. So to work with this account, we would need that amount of money, $259,491.45 at the beginning. If we want to satisfy this being able to take out $25,000 each year for 15 years. So how much total money are we pulling out of the account? So if I want $25,000 each year for 15 years, well, that's 25,000 times 15. So I want to have access to a total of $375,000. So that's how much money I would be using up if I'm taking out $25,000 each year for 15 years. But I don't have to build up that whole amount. Like, I don't have to have my account starting with that exact amount because of the interest helping us out. The idea that when I start taking money out of this account, interest is going to keep adding on. So that's where we only need this $259,000 when we're starting, is because interest over those 15 years is going to keep bumping it up. It's not going to bump it up a ton, but it'll be enough to kind of space out how we use up our money over 15 years. So in terms of how much of that money is from interest, this works a little in reverse of what we did in that last scenario, which is the fact that we want to use $375,000. And if we take out that amount that we need to build up, that $259,491.45, the difference between those is going to tell me the interest that the account is going to grow by. Because overall, if we're tracking the account, it should have the idea of $375,000. It's just not all happening at once, but it's that interest kind of adding on over those years. So 375,000 minus 259,491.45. So from this account, we're getting $115,508.55 from interest. This is a good account. I like that. So the bank is pretty much providing us with that rest to make up that $375,000 over those 15 years. All right, one more scenario here. So after retiring, you want to be able to take $800 every month for a total of 25 years from your retirement account. The account earns 6% interest. So how much will you need when you retire? So we're looking for A. We don't know what A is. We want to withdraw $800 every month. So D is 800. N is 12 since it's monthly, and then T is 25, and then a 6% interest rate, so R equals 0.06. So A equals 800, parenthesis 1 minus, parenthesis 1 plus, 0.06 over 12, parenthesis to the negative 12 times 25, all over 0.06 over 12. And we're going to plug that into the calculator. Okay, so go ahead and start fresh here and just type all that in. 800. 1 minus 1 plus 0.06 over 12 to the, oops, sorry, mistyped there. Oh, close parenthesis, exponent of negative 12 times 25, all over 0.06 over 12. So $124,165.49. 124,165.49. All right. So we would need $124,165.49 when we retire if we want to be able to take out $800 every month for a total of 25 years if we're getting that 6% from interest. All right, so just to summarize with the payout annuity, this is the idea of using up our savings account, so making monthly withdrawals, yearly withdrawals, so taking money out so that we can use it and just understanding how long that account will last for based on the fact that we do have interest that is increasing the account at the same time as us withdrawing money from the account.